Hexadecimal binary system. This system is used by the computer and works the following way. With the code that we have taught the children, numbers are formed. We can see on this side we have the units that can be up to a maximum of 15, and in the second position there will be hexens. At this point, we have that the units represent the number 15. If we take away number 2, then the number 13 will be represented. If we take the red one away, the number 7 will be represented. Let's see what happens when adding two hexadecimal numbers. We have two units to add up, one above and the other below it. We remove at random some pieces and proceed to do the addition. We are going to add this number that represents 9 to this other that is 6, whose sum equals 15. In the case that we wanted to add one more unit to this 15, let's see what happens. Like the child has already understood, two yellow pieces which are in the same position cannot be together. So she must buy a green one. And as soon as two green pieces are in the same position, she must buy a blue one. As soon as there are two blue ones in the same position, as well a red one must be bought. But here in the same point, two red pieces cannot be together. So a unit of the following hexen is bought instead, disappearing both red ones. This piece will represent the number 16, being the following position empty. We can see more clearly in the 4 buttons that the circles have. They are designed specially for this function. The number that we have above will be represented the following way. An empty position of units, and the position of the hexen with an alone yellow point, multiplying its value, that in this case is 16. This way, the number 16 will be represented. Let's see a logic problem that is solved by the computer using its hexadecimal system, internally without necessarily knowing what it is doing. From what the child has learned, the computer is going to add up. In this case, 16 plus a number that does not need to be explained. Because it is equal to 16 times 5 equals 80 plus 8 equals 88. It needs not to be known because this is simply a game of logic. So we have 88 plus 16. Let's place here the result of the process. If we continue going down, we see that the green piece goes under. And so do the red and yellow ones. But we found two yellow pieces together. So we retire them and buy a green one. And this is the final result. If we see it now, we find 6 times 16 plus 8 equals 104. This logic game is to understand how the computer works. When the computer is told 5, it does not understand 5. What it does is to convert it to binary hexadecimal system. And this works the following way. It knows that with 4 yellow pieces, it can buy a blue one. And this is done internally. The computer does not know what it means, or what it is told, or what the result will be. This is why there is no need to explain the child the value of each piece. For example, we place a red dot but also remove all the previous result. We do not know what it says, we do not know which number it is, but we are not interested in it either. Let's see which the result is. We place the green on its position because there is not another green piece. And then we find 2 red pieces. So we must buy 1 unit of the next unit, which waits to see what happens on that row. What happens is that we find 2 yellow dots plus 1 existing one. So we buy 1 green piece and place the remaining yellow piece on position. And then here just place the blue piece. This is the result. What does it mean? Which was the question? Which is the answer? A computer simply answers this. We are asking, what is this plus this? To answer the question in the same language as the answer, a computer then does the hexadecimal conversion.